This is a quick lesson on the motor principle. Hopefully you watched the brief video showing a very simple Faraday motor, just to get an idea of how this might work. This idea applies to meters that we use to measure things related to current, like voltmeters and ammeters. They are built using, or at least they were originally built using this principle. And we're also going to start seeing how the more modern motor was built based on it later on. So the motor principle states that if a current carrying conductor is placed in an external magnetic field and the current and the field are not parallel, a force that is perpendicular to both will be put on the wire. And magnetic force, just as an aside, is the force felt by the conductor in the motor principle, and this actually can be noted as force sub B, because B is used for magnetic field lines. So we have one more right-hand rule to apply to what we're learning, and this is the one for the motor principle. So if you have an open palm and you point your fingers in the direction of the magnetic field lines, so in our diagram here that's B, and your thumb in the direction of the conventional current, then your open palm faces the direction of the magnetic force. So do this with me now. So point your fingers in the direction of B, so your fingers should be pointing to the right, and this is probably the most awkward one you'll have to do. That's why I drew it. So stick your hand out to the right and point your fingers in that direction. Your thumb should be pointing down, because that's the direction of the conventional current, so you can see that your palm is going out of the page. So that means the magnetic force in this case is going to be out of the page. So green there is FB. So that current carrying conductor will be forced out of the page in this scenario.